Next up is formaldehyde, or CH2O. All right, let's begin. So the first thing we need to do is get the number of valence electrons. So let's look at the atoms involved. We have carbon, which is a row 4A element, which implies that it will be bringing over 4 valence electrons. There's only one carbon in our chemical equation, so it will contribute a total of 4 valence electrons. Now hydrogen is a row 1A element, which means it's going to contribute 1 valence electron, and we have 2 of those in our chemical equation, and so that means it will bring 2 valence electrons from the hydrogens. And oxygen is a column 6A, which means it's going to bring 6 valence electrons. There's only one of them, so altogether 6 valence electrons here for a total of 12 valence electrons. Now, to determine the central atom here, we kind of have a couple choices between carbon and oxygen. And the rule of thumb is we choose the least electronegative element. So that would be carbon in this case. So carbon, because it's the least electronegative. And now we can start to draw this out. So we'll start by putting down carbon in the middle, hydrogen, hydrogen, oxygen. Draw in our first initial bonds. And let's count up our electrons. So we've used 2, 4, 6. That means we have 6 left. We can check if our octet or duet rules have been fulfilled. And so 2, 4, 6 on carbon, it needs 8, so no. There's only 2 on oxygen, so no. And the duet rules for both of these hydrogens has been fulfilled. So we're going to draw this again, but we're going to add in our valence electrons, and that's going to go to the periphery atoms first. So we have H, C, H, O, and we need to put in 6 valence electrons. So that will be 1, 2, 3, 4, 5, 6. There's none left over, so we've used all 12 valence electrons. There are none left over. We will check our octet rules here. So carbon still only has 6 electrons in its valence shell, so its rule is not fulfilled. Oxygen now has 2, 4, 6, 8, so its octet rule is fulfilled. And the duet rule for both these hydrogens is fulfilled. Now to fix this octet rule for carbon, all we need to do is bring those electrons in to form a double bond, which will give us HC double bond O and another H connected to the carbon. So this fulfills all the octet rules of oxygen and carbon and the duet rules of hydrogen. Now we can make a model of this. Okay, so here is our Lewis diagram, and we're now going to build this in a model. So here's my carbon, here's my oxygen, here's my hydrogen, my other hydrogen, 2 single bonds and 2 bent bonds to make a double bond. So let's start building this. I'm going to start with the carbon bonded to the oxygen. Okay. And now we'll add on the hydrogens. And here is our molecule. You'll see that it's straight with the carbon and oxygen double bond with this slight bend, this bendy shape between the carbon and the hydrogens. This is going to be trigonal planar, just like the phosgene example we saw earlier. So we can also get this same determination by looking at the electron domains around the carbon atom. So let's count those up. We have 1, 2, 3 total domains, and they are all 3 bonding. There are no lone pairs or non-bonding electron pairs. When you look that up on your table, you'll find that that fits the trigonal planar geometry.